showed it during the first day. And over on this side, we put pure substances. And on this side, we put mixtures. Okay, and I didn't say anything about the mixtures. We just talked about the pure substances, and there were two types. For our two types. Antonio, could you tell me what I'm talking about here about pure substances?
Elements and compounds.
Good deal. Elements, compounds. Okay, and we've studied those. Now, mixtures. Well, first let's have a definition. We have two or more substances in no definite ratio, as opposed with compounds. Remember, you had two or more elements in a definite ratio, and these are usually easy to separate. Okay, so, in other words, a little of this, a little of that. Most things we run into in everyday life, like foods and so forth, those are mixtures. Not 100% of the time, but almost exclusively they're mixtures. Or other things you run into in everyday life, shampoos, conditioners, makeup, any of that stuff tend to be mixtures. Okay, but there are two kinds of mixtures. Okay, we have homogeneous mixtures. Okay, to the eye, they appear the same throughout. Okay, homogeneous. If you just look at, now I can hold this up. Remember, this is the beaker, I have the water. We are assuming Pasadena water is pure, just H2O. Lies, but for the discussion, it's just pure H2O. And I put some sodium chloride, table salt in. That's a mixture. Because I could have used a half a beaker, I could have used 3/4 of a beaker. Let's say you have a sore throat, and you think that the cure for your sore throat is to go home this afternoon and make a hot salt water and then gargle it. Make a hot salt water solution and gargle it. So you may use a half a cup of water, a huge glass of water, and then you put a teaspoon of salt in or a tablespoon of salt in, just whatever you want. Stir it up. That is a mixture. Take two or more pure substances, no definite ratio. A little of this, a little of that, you don't measure it. You just do it. Now, salt water, once you stir it up and you get the salt to dissolve, which is a physical change, it appears to your eye to be the same throughout. You can't see that there's salt in here. And you wouldn't tell there's salt in here. In the lab, we have to run some tests, or at home you can taste it. We don't use the taste test in our lab for obvious reasons. Okay, so it looks to your eye to be the same throughout. Homogeneous. Where have you heard that in everyday life? Homogenized milk. Just pronounced a little bit differently. What do they mean? If you've ever lived on a farm or seen a cow really give milk and have the milk sit around, cream rises to the top. It is not homogeneous. You can see a layer of cream, you can see the milk below. They take the milk, they whip it up, I think, and elevate the temperature a little bit, whip it up and turn it into a homogeneous mixture, because the milk we buy, we don't want to see it layering out. We want it to look the same throughout. Oh, we want low-fat milk where there's not so much cream in it. So, everyday word. Also, you can use it in other ways. Like, at lunch today, if I were eating lunch with somebody, I could say, oh, my 10 o'clock class, it is a very, well, I got to use the new word, heterogeneous. And that's the next one I'll write up there. It's a very heterogeneous group. In other words, not the same throughout to my eye. Homogeneous or heterogeneous mixtures. Again, to the eye. is not appear the same throughout. Okay, so what I was saying about you, I'm not saying anything bad about you. I say, I have a very heterogeneous group in my 10 o'clock class. What do I mean? Okay, I've got people of different ages. I've got males, I've got females. I've got people from this country, from other states, from other countries. I've got quite a mix of people in this class. Now, on the other hand, if I taught at a private women's college, I would have probably upper middle class, because they got to pay the tuition. Okay, upper middle class 18-year-old women. So that would tend to be a rather homogeneous class. Okay, but here in a 2-year college, to make it much more interesting for us teachers, it's a very heterogeneous class. So, homogeneous, heterogeneous. Well, hey, everyday words, homosexual, heterosexual. Homo means the same, so you're attracted to the same sex. Heterogeneous, or heterosexual, that you're attracted to the opposite sex. See, it's a sex education class as well as a chemistry class here. So, I think if you connect these words with ways you've heard similar words heard, it makes it easier to remember. So with the mixtures, there are 2 types. Okay, no definite ratio, we've talked about that. Now here I have sand. Usually sand is silicon dioxide. Okay, I put this into Pasadena drinking water. I can stir for the rest of my life, and this is never going to dissolve. So I have here 2 mixtures. I dumped in a little salt, I dumped in a little sand. Homogeneous, heterogeneous. Okay, now, you told me if I wanted this salt back, what I could do. I could heat it up, let the water evaporate, we get the salt back. That's not too hard to do. Is it easy to separate? Okay, now, this solution, I want the sand back. It's very valuable, I want it back. Okay, could I boil the water off the top? Sure, that'd work, because the sand's not going to decompose at that temperature. I could just slowly let it evaporate. How else could I get the sand back?
Filtration.
Filter. Like your Mr. Coffee filter thing at home? Okay, then the laboratory. And you will be filtering real soon. Remember the funnel you had? Okay. This is like your Mr. Coffee setup. But it doesn't fit that thing. So we have to play kindergarten. We got to take a filter paper. You fold it in half. You fold it in half. And then you put it down in here. You split it where 3 sides go one way, 1 side goes another. You put it in there, and it doesn't stay. So what you need to do then, let's see, I thought I got a water bottle. Well, I'll just use tap water here and do it easy. Okay, what you want to do, not with Pasadena water, with distilled water. You just dampen this before you start. You can use your wash bottle, and that's what I was missing this morning. And then, with a super clean finger, without a long fingernail, you just press it in there to get rid of air bubbles. Because if you have air bubbles, it's going to slow it down. So you want to be careful, because if you have a long fingernail and you slice it, it's worthless. And then you put it on a ring stand. Get something to catch the filtrate, the junk that's coming through, and just pour this through, and we'll get the sand back. And here's a good trick. Everybody's always in a hurry. If I stir this up and then dump it in there, it's going to take a lot longer than if I let the sand settle, and then I just pour some of the liquid off the top. And it really helps your flow rate. If you let that stem touch the glass down there, that really makes it go faster for some. It's like magic. And then you just pour that in there and then transfer the rest of it over. Okay, now there is another technique. What you've mentioned, boil the water off the top. And then several of you say, go filter. Oh, that works great. If you have a steady hand, you can also do what they call decanting. And so you just pour. Now you're going to lose maybe a little bit of sand. That's fairly good separation. Then we dry this, we got our sand back. So you can decant. You can filter, you can decant in certain situations, or you can evaporate the liquid off the top. So and I think in everyday life, you hear about wine decanters. Okay, sometimes if you buy, only if you're 21, listen to this part, 21 or older. If you buy wine, sometimes there's little particles, solid gunk in there. Okay, you let it sit, so the solid will be at the bottom, and then you pour the liquid off the top. You're decanting, and you're trying to leave the particles, the solid particles behind. You don't want them appearing in the wine glass. So you're decanting. So you may have heard that term. Now, anybody have a question so far of anything you heard this morning? Okay, let's move on then. That was section 6. We are ready for measurements.